All right, let me ask you this then. When we're talking about angle pair relationships, we're talking about, well, think about what that means. Pair. How many are we talking about? Two. Yes, sir. Good conversation. So when we're talking about angle pair relationships, we're talking about the relationship between two angles today. So complementary angles, it's not because they're nice to one another. They don't give each other compliments saying, "You have a really nice sweatshirt today. I like your tie-dye." They're not being like giving you a compliment. They actually just add up to equal 90 degrees. So two angles add to 90 degrees. If they add to 90 degrees, what do they form?
Right angle.
Two angles add up to 90 degrees, they form right angles.
Yeah.
And then supplementary, you're right. They add up to 180. Now, I have the dumbest way to remember this, and you guys will probably agree. So this is a really difficult question. What comes first in the alphabet? The letter C or the letter S?
S.
I knew the whole question.
Let's try this again. The letter C. What number comes first in the number line? 90 or 180?
180.
Whiskey, enough. Okay. I get it. I know you're messing around, but other people don't want to hear it because they want to make sure they get it right. Okay. I understand. You got it. So let's start over. What comes first in the alphabet? C or S?
C.
Okay, wait a minute. What comes first in the number line? 90 or 180?
90.
So complementary goes with 90 because they come first in the alphabet and the number line. Supplementary goes with the 180. That's it. It's the easiest thing to do. It's the dumbest thing to way to remember it, but it's the easiest.
Loft House always said, you always want to compliment somebody if they're right. And I was like, what? Why would I do that? I like this. So that you compliment the right angle.
I like compliment someone is right.
So complementary adds to 90, supplementary comes to 180. Terrible?
No.
All right, very easy. Now, one of the things you will see abbreviated. What do you think that stands for? Complementary. Yes, sir. What do you think this will stand for? Supplementary. Sometimes I put a 1P, sometimes I put 2. I don't know. It just depends on the mood. Just so you guys know.
They put like a P in parentheses next to me.
Yeah, like it varies sometimes.
How about I just do this last? And then you can throw things at me if I forget a second.
Okay, well, I have this.
You're lucky I'm not yelling at you.
Thank you.
All right. The next one we have are what are called adjacent angles.
Oh, Jason.
Adjacent. What do you think the word adjacent means?
Is it an angle that looks almost like Jason? No, I'm joking. Isn't it a wall?
Like they're adjacent.
That's what she's. That's what.
Just leaning against the, yeah, just leaning against the wall. Hey, it means lean against the wall because the teacher is leaning against the wall. Adjacent basically is angles that are next to each other. Angles that are next to each other, real easy way of looking at it. Angles next to each other
So like the
they
wall.
share a side, but no interior points. This sounds weird.
What? Share a side, but no interior point?
And like I said, it sounds very weird, but you worked with them yesterday. You worked with them every problem you did yesterday with the angle addition, with the angle bisectors, every single one of those were adjacent angles. You just didn't know that's what they were called. You saw this in every diagram. This seems like a very weird concept, this whole idea of points in between. Well, when you think about it, all it is, here's your angle. If I draw this, and it doesn't even matter if it's bisect or not. So this is angle A, B, C, and this one's D. Angle ABD, and angle DBC, those two would be adjacent. They're angles right next to each other. They have that common vertex. I should write that too. Share a side, each other, right, common vertex. Sorry about that. Common vertex, and they share a side. So they have this common vertex B. They share the same side, BD, but none of the points inside are the same. That's all that means. That's all it means. See what I'm saying? It's the points on the interior of it, because if you start plotting these things in like a two-dimensional plane, you have ordered pairs that are solutions of those values, and we're not looking at that. Yeah.
Wouldn't it be easier to draw a picture and explain it instead of words?
Well, that's why I drew the picture.
Because words are way more confusing.
I agree. That's why I drew the picture. I wanted to write it out. What's that? Yeah. So again, when you draw it out, it doesn't necessarily have to be a bisector. Would a bisector create adjacent angles?
No.
Yes.
It would?
Yeah. Because if you think, remember what a bisector does. Right here, let's draw this. If I bisect this one here, I make these two angles the same, right?
No.
Just looking at, are these points in these?
Yeah. No.
No. All these go over here. All these go over in here. Do they overlap? The red and the blue overlap?
No.
No. They have this ray in common though. They have that in common, and they have the same common vertex. So it could be a bisector creates adjacent angles. It doesn't necessarily have to do that. Any two angles that share the same vertex have one side that's the same, they're adjacent. They're just next to it. You're just next to each other.
I should use these kind of angles
The what?
for my drawings.
You should what?
I'm thinking about art right now.
Oh, okay.
Mr. Murphy, who's next?
Miss T.
Okay, so like this wall is adjacent to Miss T's classroom, because we share a wall. Okay, so what?
You feel like punch a hole in the
Just
wall.
he's definitely not being a smile if he knows like that. I dare you say.
We're angles.
Oh,
We're
so
adjacent.
here-
We're adjacent angles.
Say if you run like that, you definitely.
Look, we're adjacent angles.
Look at that.
Hey, Mr. Murphy. Hey, Mr. Murphy.
What?
A few days ago, you said you were faster than me and can
Yeah.
beat me.
Yeah.
But I just saw you run. You cannot.
He was running around, there's books here, right? There's like people moving stuff. Yeah, whoa.
Yeah, I can dodge those people pretty darn fast.
Because he's freaking out legend.
Whiskey, I really hate for you to get shown up by an old man.
Oh, come on now.
Two more. We have what's called a linear pair. Gee, what do you think linear is going to stand for? What do you think, Wisdom?
Isn't it the same?
No.
Oh, she screwed me up. I did. Well,
Sarah.
if you don't know math, stop talking.
We got that.
We in the same class before.
Yo. It means
All right, linear pair. Remember, we're talking, gentlemen, we're talking about angles today, okay? We're talking about angles. So a linear pair is going to be a pair of angles that form a
A linear.
A line. It's two angles, and I'll go with the diagram first for you. Two angles
Thinking.
that are adjacent to one another form a line. That's it. Angle 1 and angle 2. So two adjacent angles.
That forms a line.
Is it okay if I abbreviate adjacent as ABJ?
Absolutely not.
Adjacent angles that create a line. What do you think the sum of those two angles is going to be? 180. Linear pairs create 180 degrees. So in this example, angle 1 plus angle 2 will always equal 180. So anytime you're given a linear pair, it means the two angles add up to equal 180. That's what that means. Yes, sir.
I use the bathroom.
Yes, sir.
What was the other one?
What's that?
I said what was the other one? Next one.
Oh, I'm getting it. We okay on that one?
So, wait. Would the bottom be as well 180?
Yes, sir.
Alright.
Yeah, but we just don't have anything drawn there. This angle here, if you went through it, if this was labeled, let's say X, Y, Z, you could say angle X, Y, Z is 180 because it's a straight angle there. The other one we have are what are called vertical angles. And you saw this yesterday in that one diagram that I think Austin, you were saying there was like 160 degrees where it flipped across the axis like that. What happens here is that anytime you have two lines that intersect one another, when you have two sets of opposite rays, remember opposite ray?
I know this one. I know this one. I know this one.
Hold on, Mister. Hold on. Anytime you have two sets of opposite rays, anytime that happens, they share this common vertex, this common spot right here. It means angles that are opposite one another,
You're going to be the same.
they're going to be the same. So this angle here is the same as the angle
Right there.
below it. This angle here is the same as
angle to the right.
correct. So that's how that stuff works. That's what vertical angles look like. Vertical angles are always going to be congruent. Vertical angles are created when lines intersect. Because if you think about it, no matter how you draw two lines intersecting, how many angles are created? 4 of them. But in essence, there's only 2 of them, 2 different measures, no matter what. You can't draw two lines intersecting and have more than 2 different angle measures. Is there a possible way to draw two lines intersect and only have 1 angle measure? How?
So I'm drawing a right angle.
Very good. You draw a right angle. Okay. You draw a right angle. Because you draw one right angle, that means everything will be right angles. Because of linear pairs, because of supplementary, things like that. Okay. So vertical angles are basically opposite angles across from one another are going to be the same. Okay. Does that make sense?
Yes, sir.
What's that? Sure. 2 lines intersect, then angles. You want to see? I don't want to say opposite because that might across from one another.
Across from another
Is that you okay if I say across from one another? So this one's across from here. This one's across from here. Then angles across
equals
each other
equals
are congruent. Yes, sir.
If all those angles like add up to this 160 and whatever,
Not 160. They all would add up to equal.
360.
Very good.
there's not
Yep. Yep. That's a good point because when you have 2 lines that intersect, whenever you have 2 lines that intersect, you know that you're going to have, let's say this is angle 1, angle 2, angle 3, and angle 4.
You always have a circle, and the circle is always 360.
Right. What does angle 1 and angle 2 have to add up to equal? 180, because they're a non-adjacent linear pair, which means they're an adjacent linear pair, so their sum is 180. Well, what does 2 and 3 have to add up to equal? 180. What does 3 and 4 have to add up to equal?
180.
And 1 and 4?
180.
180. So what happens is, since these two are the same, and these two are the same, if I go from here to here is 180 degrees, then I work my way back, I'm at 360 degrees. So anytime you go all the way around these 4 angles where 2 lines intersect, it's always going to be 360 degrees. Okay? It'll always be that. And then,
And hallelujah.
let me show you some examples.
Wasn't that wasn't the homework last night?
All right, angle 1. This is another thing this book does from time to time for the typesettings. They accidentally, sometimes it shows up as this for an angle symbol. Just remember, it just means angle. Okay. I don't know why it does that. It's like it's yelling at you again. I won't yell at you right now. Maybe later.
It's not in the textbook though, right?
No.
It's just.
The worksheets do that for some reason. So if angle 1 and angle 2 are complementary, well, angle 1 is 52. What's angle 2?
52.
Angle 1 and angle 2 are complementary. What is it? 38. How'd you figure that out so blazingly fast? Subtract from 90. Very good. Remember, guys, complementary angles and 2 angles add up to equal how much?
90.
90. So if angle 1 is 76, what would angle 2 be?
Something 24.
14. Very good.
I was supposed to be 24.
Sine plus 2.
When you're subtracting, you gotta make sure you watch out how you borrow stuff. Use your calculators. You'll make a silly mistake. What happens if they're supplementary? So if angle 1 is 121, what's angle 2 if they're supplementary? What would you do?
180 minus 120.
And what do you get? 59. See how easy this is? Now you're probably all waiting, okay, I get it. The math isn't hard. When is he going to throw the algebra at us and make everybody mad? Well, I'll do that. I'll do that right about now.
Okay.
Whoa. Why?
Let's take a look at this diagram. In this diagram, we have 2 angles. We have angle ABC and DBC.
Okay, ABC is going to be 180.
Hold on. Let everybody get a shot at it. So if I start by looking at what we have, what angle pair relationship do we have, ladies and gentlemen? They're adjacent, good, but more specifically, why should they equal 180? There doesn't say they're congruent, doesn't say it's bisected. Why should they equal 180? Because it forms a line. They're a linear pair. Okay? These guys form a line, they're a linear pair. Therefore, what do the 2 angles have to add up to equal? 180. There's the algebra. Recognize that you have a line, which means they're a linear pair. So it's 4x and 6, 11x minus 6 equals 180.
Whoops.
Were the directions just to solve for x or to find an angle?
I'm glad you asked because I just forgot. Find ABB and DBC.
Yeah, I tried by X and
So,
ABB.
so first we're going to have to solve for x, then plug x into.
Yes, sir. So let's see. 4x and 11 is?
For 15. 15x.
And 6 minus 6.
0.
Divide this out, and I do believe we get 12. What do you do with that 12 then, ladies and
Oh,
gentlemen?
you plug it in. X.
Exactly. So double 12, what do you get? Double it again, you get 48. 48 and 6 is?
54.
We got 54 there. And then after that, go ahead and start going, use the calculator if you have to. We have 11 and 12, I believe is, what is that? 132, thank you, 132 minus 6 is 126, I think?
Yeah, you're right.
So if we did everything right,
Oh,
what do you get with 54 and 126?
180.
Yay! Math.
I'm so smart.
So you only have to plug in once.
You go to both. You always want to go to both of them because in this case it did ask. You'll see in the instructions here it said find those two different angle measurements. So you want to do both of them, and then it only takes a second just to make sure they add up to 180. Because if it adds up to 173, you know you messed up. So, all right. It's always good to double check your work. Always good to double check. Okay. What about using a little bit of both, a little bit of everything here? Hold on, Whiskey. Hold on. Thank you, sir. I appreciate it. Well, let's take a look at what happens when you have x's and y's.
Oh, God.
You have to start making decisions on what angle relationships you want to use. What are you going to set them up as? What do they look like? What do you think you want to do? Things of that nature. So, if I look at that 4y and then 9x and 5, does everybody agree that those are vertical angles?
Yes.
So they have to be equal to each other. But can I set a 9y equal to a 4y equal to a 9x plus 5?
No.
No, I can't solve for two different variables at the same time. So I have to then solve for what first? X. What's the relationship with the x angles? What do they have to add up to equal? 180.
Oh, yeah.
The two of them have to add up to equal 180 because they are adjacent they're next to each other forming a line, which means they are supplementary, which means if you add them together you get 180. So we do that first. 16 x plus 9x plus 5.
Equals 180.
This actually works out real quick. We have 25 equals 175. How many quarters are in $1.75?
4.
What?
7.
What do I do with that 7 then to help
Plug it
me
back
solve for
in.
y?
Plug it in for x. 16 times 7 is some number.
Correct. Now I can do one of two things here to solve for y. One of two things. I can set these two equal to each other because they are vertical, or I can add these two together and set it equal to 180. Doesn't matter which method you choose.
No.
Not at all. Not at all. So I'm going to use the vertical. What's 9 times 7? 63. Yeah. 63 and 5 is?
68.
So 4y equals 68. Y is?
Yeah, that's 60.
Oh, yeah.
And there you go. And you would get the same value with either one that you choose. It's just a matter of remembering. All we're doing, guys, is we're bouncing back and forth between linear pairs, vertical angles, supplementary angles, things like that. I'm not trying to get too crazy here today at all. All right. Tomorrow we'll do a little. Basically tomorrow is going to be algebra, a lot of it. But here it's just straight away. Now I think the problems I had, I might adjust what I put on. What section is this? It was 1.5. Let me check here. So it's page 39. Let me make sure these are the ones I like. I wrote this the other day and I wasn't sure if I had gotten as far as I wanted here. I'm just double checking to make sure the numbers that those are the ones I want. I think I might want to cut. Okay, go 31 through 38. 31 through 38, that is set. No, I'm sorry, not through 44. Go 31 through 38. So it's 17 through 27, 31 through 38. The 17 through 27, there's only 3 of those have algebra. The other 8 of them are just list what kind of angle is it. And then there's 3 more. There's 6 algebra questions, and the other 10 or so are just what kind of angle is it. Yep.
And everyone can start right now, you guys.
Yep. Knuckle head. Yeah. So I'll adjust it on the. I will adjust that on the calendar also.
Jason. Jason. I heard you're supposed to come.
Are you getting flex back?
So why do you want it? Jason, you gonna be in here? For what? Huh?
Yeah, at least let me just start with these so we can blow it up a little bit. Here's at least the first handful for you guys so you can start on the first few of them because you got a couple of minutes. Okay?
So what
Out.
was the whole
17 and 27.
good shit,
And
man?
then 31 to
17,
27, and then 31
37 or 37?